Hello everyone, I want to say February, it's March the 8th. Alright, today is a bit earlier. Just finished collecting data. Did one round of data collection at night. Actually, it's pretty nice collecting at night. It's still hot down here, but no sun. That's a big plus. Alright, no sun, that's a big plus. Can handle. I also collect data like at what 11 a.m., 12 p.m., 1 p.m. Well, the sun is so huge, I have to really wrap myself up to not get sunburned. At night, there's no such issue. Well, the only thing bad is just it's hard to see. That's the thing. It's dark, but you win some, you lose some. All right, let's try to see what we have today. Remove duplicates from sorted list. Okay, when was the last time we did this? The first time was 2019, and then tried again. Ooh, look at all these submissions. All right, that's last year, January. All right, given the head of a sorted list, delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the list sorted as well. So it's already sorted, and you just want to remove all the duplicates, right? Guaranteed to be sorted in ascending order. All right, so the first thing in my mind is this 2 pointers, right? I have 2 pointers, and if it's not the same, then both walk forward. Like here, just 2 point walk forward, and 2 pointers here, and the next one is the same. Okay, I just realized I can't do it this way because this thing needs to be removed as well. I mean, we can go like 2 paths. All right, we can do 2 paths, or we need 3 pointers. All right, we need 1 is always in before. This is the current, and I can check. Yeah, current on next. I just check current on next. So 1 is I call it anchor. Okay, we call this anchor. Anchor and a current. All right. So anchor and a current. And a current I compare to current on next if it exists. So if it's not the same, current move forward, anchor move forward. Compare, not the same, current move forward, anchor move forward. Compare, oh, it is the same. So anchor doesn't move forward, current move forward. Compare is not the same, then we can do not the same. And we have to have a flag saying that it is the same. So right now it's not the same. And then what we can do is anchor next equals current dot next. Oh, that's it. That's all we need to do. Anchor next equals current. I don't really care about this. I mean, if we want to care, we can just say current next equals none. So we cut this off, and now we say current equals anchor dot next. All right. Then we do the same thing, and this will work with this as well because this is the anchor. Anchor is the dummy node. Current is here. I compare the same. Just go forward. Now it's not the same. I do this operation, and then afterwards, current be yeah. So not too hard. Quite straightforward, if you ask me. I didn't expect it to be this slow. Come on. Well, that's ridiculous. It's not opening up. What the hell? I have to force it to open. God. Man, this laptop is getting old. 2017. I've got a lot of mileage on this laptop. Yeah, if I buy a new one, I'll get another Apple for sure. I'm just used to using Apple machines. Alright, delete duplicates. What do? Well, we have to get a dummy. Alright, dummy will equal to a list node. Next will equals head. Alright, and then we have anchor and current equals dummy and head. Right, and we say while what? While current. Let's do while current. And then we say if current.next, right? And current.next.val is not equal to current. Right, this is the way we check in. If the current.next, we also need a flag. Is consec is false, right? It's not equal to current.val. Then anchor equals anchor.next. Current equals current.next. That's the easy case. Elif. Hold on. What if current.next? What if the current is here? Well, it depends on whether if it's all the same. So you know what? Hold that thought. I actually don't like it. I think I should check. The next one is not the same. Let's check the next one is the same. Because it have to be if current.next and current.next.val is equal to current.val. If that's the case, is current_sec will be true. We'll just keep setting it true. And then current equals current.next. Right? And then else. Right? And this else has two situations. One is current.next does not exist, or this. So we're going to say, but it doesn't matter. Else if is consecutive, right? Which means either of these doesn't work, but then is consecutive is true, all right? So that means we have hit something that's not the same. Now we're going to do the operation. Right? How do we do the operation? We say anchor.next shall equal to current.next, right? And then current.next equals none, just to cut it off. And current equals anchor.next, right? And we go back up. And then when we're done, we return dummy.next. All right, let's try. Not trying here. Let's try over here. I have like empty. Yeah, I have to check the empty case as well. Ooh, something is not right. Something is not right. Alright, so I probably didn't move forward. Alright, so let's walk through this. Current.next, and current.next, no. Oh, we forgot the other case. Come on, man. I forgot the other case where is consecutive false. So it's not consecutive, all right? So previous not consecutive, but now we have found out that it's not the same, right? Then we just move forward. It's not the same. Then anchor equals anchor dot next, current equals current dot next. I can't believe I forgot about this case. Try it again. Ew, that is ugly. The heck? Alright, I'm going to do it again. So, current dot next and it's not the same is, oh, we have to reset is consec. Ah, shoot. So, that's true. So, whenever this happens, we have set is consecutive equal to false. Now we try. One more time. Still not right. Okay, let's see. So this is not the same, and then if it's consecutive, no. So we set consecutive false. Anchor equals anchor next current. Anchor is pointed at 1, current pointed this. And come back again, it's not the same. Right? It's not the same. So anchor's here, current's here. Coming back, now they are the same. So now we say is consecutive is true, current equals current dot next. Come back up. That's not the same, and is consecutive, right? And then anchor's here, anchor dot next equals current dot next. So these two connect. Current dot next equals none. This one is none. Current equals also current point here. Then go back up. Current dot next and then current dot next. Oh, it's still the same. So if current is true, current moving here. Anchor still at 2. And then this one is not the same. Is current anchor dot next equals. Then we do anchor dot next. Anchor dot next equals anchor dot next equals current dot next. Current dot next is nothing. Okay. And then current equals anchor dot current is here. Now next one. I see. I have to set this one here as well. I said so many times. It feels. Yeah, that's fine. I mean, another way is just we do a one else here. So I can say, like, we can do this way. We say else, right? I say if, do this, and this one we just do it one time. Right, else, and then we set it here. I was trying to see if it's possible to. Nah, I don't think it's possible. Anchor dot next equals current dot next. Yeah. Alright, try this. There we go. There we go. Alright, so one more test case we need to run. That is empty. We need to run empty case. Yeah, I forgot the reset is consecutive. Yeah, it's good. Alright, let's go. Alright, done. Wow, it's not as good as the other time, but I guess it's fine. We can take a look at the, what's this, 32 2-millisecond solution. It's ON 73 and 23%. I also want to see the details as well. So 82, 82. One pass solution. Very straightforward. So I don't want to write anything else. There's nothing to write, man. I'll take a look at the solution, but I don't think there's anything interesting. Alright, that was back then. What type of method I use? 2 pointers instead of 3. I use 2 pointers. Same, right? 2 pointers. Slightly different in the logic, but overall I think it's the same idea. So I was saying then, that's true. Else, no duplicate and no. Yeah, it's actually a cleaner logic. What do you think? Cleaner logic. And we do one more round of checking for duplication. Here I don't do that. So that's the main difference. But this one and this one, yeah, I see what it's trying to do, which I think is possible if I don't do this, right? If I don't do this, which is I just don't care of cutting the things off, all right? And then I don't need to do this, and we don't do this, and then we do this one here, all right? And in this case, Aleph is consecutive, then we do this, all right? Only set it to false. Else, it's not consecutive. Yeah, I think we can do this. It will look more similar to this solution. Sentinel head and the predecessor. Let's see. Yep, this is better. Less if and else, so we do one less if and else. Maybe it'll be faster. It's alright. Alright. Yeah, it's alright. Okay, so let's do the other one. Wow, today laptop is slow. I have to restart it. Fraction addition and subtraction. Given a string expression representing an expression of fraction addition and subtraction, return the calculation result in string format. The final result should be an irreducible fraction. if your final result is an integer, change it to a format of fraction of denominator 1. Okay? Okay. How many are we talking about? Input is this, so does the output. Each fraction has the format this and this. If the first input fraction is positive, then plus will be omitted. Alright, so the input only contains valid irreducible fractions, where the numerator and denominator of each fraction will always be in the range of 1 to 10. If the denominator is 1, it means this fraction is actually an integer. So will be in the range 1 to 10. Okay? The numerator of the final result are guaranteed to be valid. It didn't tell me how long this expression can be. Okay, so naive solution will just be, finding that is bonkers. You're finding the greatest common multiplier of all the denominators. That's bonkers. All right, that's not gonna help. So for sure, what we're gonna do is I'm trying to split, but it'll be hard because some is positive, some is a minus, some is a negative, right? Alright, so here's the deal. We'll give everybody a positive or everybody a negative. So these starting with a negative, we have the negative already. These are the positive, and this I just add a positive to the front. And then I walk through the entire thing, just manually. I manually take it out. I walk through the entire thing, and then take this, and take this, right, into, let's say a tuple, okay? So a tuple minus 1 and 2, 1 and 2, right? And then like this, blah, 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 blah. We did a ton of them. But in fact, what we want to find out is the ones with the same denominator, right? So we can reduce a lot of the computation. So for all the denominators, it's going to be a hash map. We'll put that as the key. And we're just going to add, because this is the same, so we just add the denominator, right? And after we're done, if something is 0, we just throw it out. We don't need to worry about that one again. And then we'll have the remaining values. And of course, we need to also, we need to run another round, right? We'll run another round where each one gets reduced, right? Each one gets reduced. So the sum of the denominator, we're going to find the GCD and denominator, and we'll put that into yet another hash map, right? So this hash map will contain, and then we just do this all over again, right? We just add those together until the final. So this, I was going to say recursion, but it's actually not. It's a tail recursion, so we can write it in a loop. So basically, just created the original hash map. We pass into this loop, and every loop, every step, the first either remove the stuff, right? We either remove the either remove the stuff if it does not, if it's a 0, like we don't consider it, or when then we reduce it, right? We reduce it, put it into another one, right? We reduce it, put it into another one, and then we add those together, then put it into another one, and eventually we will come up with the size will be 1. Yeah, I think that is the way to go. Do you think it can open it by itself? Come on. I don't know why. Today just didn't help. Yeah, it's just fine. Alright. This is actually an interesting problem. I like it. So first of all, I need to a if, right, expression, let's say 0, is not equal to, actually no, let's just go through, right? Let's just go through. Yeah, it's fine. It's fine. First one is fine. It's completely fine. It's completely fine. So what we need, let's do default dict. Okay. It's not called default dict. It's called counter. Yeah, we can do a counter. Okay, a counter. So we call it hash map equals a counter, right? And then for I in range len expression, right? What do we do? If expression I, I don't like it, E in enumerate expression, then we can say if E is equal to minus or plus. I just realized something. Because if this will be minus, right? So it's hard to, so I have to go a couple down. So, you know what? Sorry, man. I rechange in range 1 for the len expression. I didn't really say like how. Man, that should be fine. So, for I in this, right? And then we just, that's fine. We'll just say if expression I have to call it in plus all this, right? If expression is I is this, then what do? We need a pre, okay? Pre is 0, all right? So if this is this, right? So what we do is we grab the value out, all right? So we say numerator and denominator shall equal to expression from pre to I, but not including I, right? From pre to I, and split this, right? And then afterwards we say hash map int denominator plus equal to int denominator. And after that, we're going to say pre equal to I, right? Pre equal to I. And then back up. If it's not, we keep going. When we hit another one, then we can do it again, right? So once this is all done, we will walk towards the end, and we need to do it one more time. Right, one more time. Might as well. Yeah, that's fine. So when we're done, we just add it one more time. One more time. Then this will be to the end, which is just because last time pre is here, so to the end, split, all right, and then int this plus equal to, okay. So now we have this hash map. Now we just say while hash map, while len hash map is larger than 1, all right. I'm going to do temp is equal to a counter, all right. What do? We go say for we need to reduce it first, right? So we reduce it and put it into a new thing. Reduce it, put it into a new thing. We need to add hold on, let me think clear. Alright, so now we have unique denominators. Right? We have unique denominator with some denominator. And then what? We just add them together. Yeah, if it's a unique. Let me think. Now we have a unique, so we can just go one by one. We get this, add to this, produce something, put into. We don't have to put into a new thing. We just get a new value, and then this and this. So we can just go one by one. You know what? Yeah, I don't like it. I think we just go through the hash map, right? You can just say the result. Res num and res then equal to 0 and 0. Wow, res then cannot be 0, man. Res then cannot be 0. But that's fine. What we want to do, well, actually, let's put it 1. Right? So what we want to do is for a key for key value in hash map dot item. Okay, let's say if v is 0, then we don't have to worry about it. Right? So if v. Now, what we need to do is to find well, actually, don't have to find. We just say so v times this, right? And plus something. So we times this, and then this times this plus this times this. Add them together. So we say res num res then shall equal to res then is v times res denominator. This one is res denominator times v plus k times res denominator, right? After that, we need to reduce them. I'm going to say GCD equals math. Right, GCD equals math.gcd res norm res denominator and the res norm divided equal to GCD res then divided equal to GCD. Right, and then we just go through everything. Then we just return res nominator and res denominator. Okay, that's very different from what I had planned because I realized this is easier to write compared to the idea I have in the past. Oh, I just realized something might be wrong. We'll see. Yeah, this one shall we call 0, 1. We might got that one wrong. Alright, this one is 1 over 3, and this one is minus 1 over 6. Right? So this one is minus 1 over 6. Expression. Run it. Counter has no attribute item. So items, right? There we go. All right, this is not right. This is absolutely bonkers. I should get to 3. Which part? Which part that is not right? All right. So first of all, we're gonna print hash map just to make sure that the hash map is correct. The hash map is 2 is 0, 3 is 1, right? Oh, key value. I gotta reverse. The key should be key. Should be key. K should be V, and then this should be key. You know what? Stupid key and value. I just call it denominator and nominator. All right, it'll be easier for me to. That's a denominator, and then denominator times denominator, and this is rest denominator times denominator, and this is the 2 denominators times together. And now we shall be right. Yes. Okay, so let's uncomment all of these and try it again. Now we all pass. All right, let's give it a shot. I don't think it will time. Oh, the only expensive is the GCD, but GCD shall be okay. And I also want some like edge cases. Let's I don't know what edge case. Well, that is an edge case. That is an edge case. All right, that is an edge case, and yeah, let's do something nasty, right? 3 divided by, let's say, 7, that's 12. 4 divided by 5. 5 divided by 9. 6 divided by 10. I don't know. Something like that. Okay. Alright, let's give it a shot. Alright, we got it. So, not too bad. Not too bad. So, first, we pre-process the expression by extracting each fraction number. But we can do this smartly by using the denominator as key and nominator as value in a hash map such that we can easily compute the sum of all fractions that have the same denominator. After that, we compute the sum of all the key value pairs in the hash map, right? In the hash map. using GCD to reduce a fraction. On for this, right? And then this is also on. GCD, whatever you call GCD. I don't know. GCD is a log. So let's call log n, where n is equal to, n is the number of fraction numbers, and m is the largest value to, let's say log m is the maximum cost of GCD, math.gcd. And around is 55% ranking. So middle of the pack. Check the solution. See if there's any better ones. Using LCM. Okay. That is a solution. Yes, it could be very large. That's true. And in my solution, it's very unlikely that it will become too large, because I do GCD at every single step. I mean, like this part is only 10, right? The denominator, the maximum, maximum key is 10. And then as we go through this, we will have it getting a bit bigger, but we will reduce it at every step. Let's see. N log n, n log x. GCD